afternoon, everyone, and welcome to the second day of Veterans Advanced Energy Week. My name is Emily Burlinghouse, and I'm an assistant director here at the Atlantic Council Global Energy Center. We had a great day of panels and networking sessions and recruiter engagements yesterday, and I hope you all will have the chance to make the most out of the coming days by connecting with your fellow participants, sponsors, and recruiters. We have a pretty busy day today, and I encourage you all to join our upcoming sessions. At 1 p.m. Eastern, we have 2 info sessions with the global manufacturing company Emerson and with Apex Clean Energy, whose CEO, Mark Goodwin, is actually on this panel that's about to start. At 2 p.m., my colleague Reed Blakemore will be hosting a discussion on new energy mobility. And later in the day, we're hosting a conversation with Senator Mike Braun of Indiana, a panel on the role of nuclear energy in net zero, and a number of advanced energy policy presentations hosted by the founder of Veterans Advanced Energy Project, Dan Mish. Before we get started, a few housekeeping notes for me. This event is on the record, and we are currently live streaming to Twitter, Facebook, and YouTube. We encourage you to post about what you hear today and share on social media using the hashtag VetsEnergyWeek and by tagging us at AC Global Energy and Vets_Energy. If you would like to participate in our conversation, we encourage you to submit your questions in the Q&A portal located at the bottom of your screen at any time during the event, and we will incorporate them as appropriate. Please note, however, that only those directly engaging via the Veterans Advanced Energy app will be able to submit questions. And as a general note, you'll get the best, most connected experience out of this conference if you download our app, where you can post in the virtual cafe, submit your resume, check out the job board, and message fellow participants. Now, moving on to the conversation at hand, I am pleased to be joined today by an esteemed panel as we discuss the future of the electric grid amid the accelerating energy transition. The topic of our panel today is achieving net zero carbon electricity. Given the Biden administration's goal of reaching net zero carbon emissions in the power sector by 2035, this is perhaps more important and achievable than ever before. However, this goal won't be easy. It requires a significant mobilization of economic, political, and labor resources, in addition to collaboration across public and private sector stakeholders. As utilities, energy companies, and federal and local governments work to transition an entire sector of the economy away from fossil fuels, we are lucky to have some experts here today who are working on implementing the solutions required to achieve this goal. One of these experts is Miranda Valentine, who is the CEO of the Renewable Energy Buyers Alliance and the former Assistant Secretary of the Air Force for Installations, Environment, and Energy. Miranda has dedicated much of her career to accelerating the use of advanced energy in her jobs in the public and private sector. In addition to her appointment in the Air Force during the Obama administration and founding role at REBA, she has served as the Director of Sustainability for Global Renewable Energy at Walmart, Managing Director of Rocky Mountain Institute's Business Renewable Center, and CEO of Constant Power, a Toronto-based developer, integrator, and operator of distributed energy resources. Miranda, thanks so much for joining us today. I'll hand it over to you for keynote remarks.
Thanks, Emily. I really appreciate you all inviting me here today. And as you noted, I'm Miranda Valentine. I'm the Chief Executive Officer of 2 organizations, the Renewable Energy Buyers Alliance, which is a trade association of large energy customers, as well as the REBA Institute, which is a 501c3 think tank charitable organization. And you're right, I had the incredible privilege in my mostly business-oriented career to spend a few years working in the Pentagon, serving Secretaries Hagel and Carter as the Assistant Secretary of the Air Force. And it was just an enormous privilege and pleasure to work alongside our men and women in uniform, as well as our civilian, civilian folks in the military. And I really had the opportunity to witness firsthand the role that energy plays in our geopolitical landscape and our national security issues, from energy security to energy resilience. And it's just really a great pleasure to be able to be here and speaking with your audience. I sure wish we could be together in person so we could get to know one another better. So my job is to spend just a couple of moments sharing with you a little bit of perspective from large energy customers both why it's important to decarbonize the power system and the electrical system, as well as the role that energy customers can play. And then I'll hand it over to a phenomenal panel, and I'm really looking forward to hearing what my colleagues Mark and Anne and Tim and Bob have to say about this fascinating topic, and we'll take some questions from the audience. So just very quickly, a little bit about REBA. Like I said, we are a trade association of large energy customers. Our vision is a resilient, zero carbon energy system where every organization has a viable path to procure renewable energy. We have about 262 members. Annual revenue in our community is about $6 trillion a year. So it's a fairly substantial set of organizations. Representing over 14 million jobs. And I'm really excited to share the newest member of our community is actually the Defense Logistics Agency Energy Team. As I'm sure most of you on the video know, the Department of Defense is the largest energy customer in the nation, and the federal government's the largest energy customer. Well, DoD is the largest in federal government's largest in the nation. So we're really excited to have DLA Energy join the REBA community to both share their best practices and learn from other large energy customers. So, when we think about decarbonizing the entire economy by 2050, it's a daunting task. Carbon emissions come from a full suite of places, from energy, from agriculture, from chemicals, from aviation, across the board. So why is it important to focus on electricity? There's several reasons. First and foremost, in many ways, decarbonizing the electricity system is the easiest in this complex puzzle of decarbonizing the economy. But that is not at all to say that it is easy. There are a number of public policy and market barriers, as well as just business barriers that prevent us from decarbonizing the electricity system. So it's the easiest, but it's not easy. In order to ensure that some of the harder to abate sectors, such as thermal, aviation, agriculture, deforestation, some of those more challenging areas have enough time and runway to decarbonize by 2050, we really need to accelerate the decarbonization of the power grid. Likewise, as we decarbonize some of those other industries and sectors, we anticipate that many of them will actually electrify, increasing the load onto our power systems. Thereby, it's even more important that we ensure that our power systems are decarbonized and made more robust, more resilient, more reliable, and modernized in order to be able to absorb the increasing load that we're sending. We've seen through multiple models that it is not only possible, but affordable to decarbonize the power system in the United States up to 80 or 90% as early as 2030 with existing technologies and in cost-effective ways. And the electrical component of our overall greenhouse gas emissions is likely to grow as we continue to put more load on the system. So there are really three key elements that, from the customer perspective, the large energy customer perspective, we need to see change to get us to this decarbonized grid that we envision. Public policies and regulatory frameworks, accelerating next generation clean energy technologies. And then the third is probably the most nebulous, but equally important, and that is really shifting the inertia and business practices that we have today using yesterday's energy technologies. So I'm going to touch on each one very quickly, and then we'll transfer over to the panel, Emily. So first one, public policy and regulatory frameworks. It's quite clear from the energy customer perspective that if we unlock energy markets, that then large energy customers, whether it's the Department of Defense or any of the three agencies or cities or universities or large corporations like most of REBA's members, the Fortune 100 companies and all companies, in order for them to use their buying power to send a clear demand signal for zero carbon energy, we know that having wholesale electricity markets is a fundamental underlying regulatory framework that is critical. 80% of new renewable energy projects have been done in wholesale markets. And that is all new renewable energy projects, whether it's corporate off-takers, utility off-takers, co-op or muni off-takers. These deals are happening in wholesale markets where generation companies can compete for lowest cost. And we've seen this play out over and over. In ERCOT, we have 18 gigawatts of renewable energy beyond the Texas 2025 Renewable Portfolio Standard. In PJM, customers in PJM see $3.2 billion in annual savings and 34% lower emissions thanks to having an organized market. And studies looking at the West and the Southeast, where we don't have organized markets today, estimate that in the West, customers could see 1.5 billion in annual savings just by California ratepayers. And in the Southeast, studies are showing that customers in the Southeast can save $19.2 billion per year, and we could lower emissions by 37%. So this bottom-up organized market framework is really important to decarbonizing the power system in a cost-effective way. Likewise, from a public policy perspective, we really believe that we need some top-down ambition. So something like a clean energy standard. In fact, the REBA Institute and Resources for the Future just noted last week that the net benefits of a federal clean energy standard that is well-designed and market-oriented, that is customer-centric and allows markets to work, could bring to the order of $100 billion per year in net savings to customers in both of the years that we modeled. And that an 80% clean energy standard by 2030 can balance ambition, technology costs, and overall cost to customers. So overall, we think these two types of policies work together, wholesale organized markets and clean energy standards, to really create the frameworks that allow us to get to this decarbonized grid. We often talk about technology. We do need to accelerate next generation clean energy technologies. And of course, we need to advance technologies that balance the intermittency of some of the intermittent renewables. There are lots of technologies available today that are zero carbon and non-intermittent that can work together, whether it's storage, hydropower, geothermal, and of course, many that are not in the renewable category, whether that's nuclear, small modular reactors, fossil with CCUS. Just last week, Senators Crapo, Risch, and Whitehouse, Reid, and Congressman Panetta, you may have heard, released the Energy Sector Innovation Credit. This is a really exciting technology inclusive, flexible tax investment credit and production tax credit that's really designed to promote innovation across a wide range of clean energy technologies, including not just clean energy generation, but storage, carbon capture, and hydrogen. Last, we think that it's really critical that we shift business inertia. And this is really helping large energy customers think different about the energy they use and buy. And that's really the bread and butter of what REBA does through boot camps and trainings and peer-to-peer education. So I just spoke really fast, Emily, and I think I still went over my 7 minutes. But I'm also really delighted to share with everyone that REBA has a number of job openings. We are growing very quickly, and I would encourage you to please go to our website and click on the careers button down at the bottom to see all of our current openings.
That was great. Thank you so much, Miranda. And I appreciate that you tailored some of your remarks to the defense and national security community. I'd like to remind everyone once again that the Q&A function at the bottom of your screen is open. If you'd like to ask Miranda a question or any of the other panelists, please feel free to use that function. I actually have one question for you, Miranda. You were talking about how the power sector is the easiest sector of the economy to decarbonize, but obviously there are a lot of challenges associated with that. And given that, a lot of our audience is national security and defense, I'm curious what your thoughts are on what the national security imperative of decarbonizing the electricity system is. And if you could talk sort of broadly about, whether there are any unifying challenges across different areas in renewable energy across the renewables industry, whether it's buying, selling, developing, that would be great. Thank you.
Yeah, well, we could speak for a full hour on the national security implications of decarbonizing the power grid. And there's so many different ways that this comes into play. First and foremost, we know with certainty that the shifting climate and shifting weather patterns has a number of just really kind of bread and butter national security challenges, whether it's impacts to our national security infrastructure, where we're seeing things like radars along the Alaskan coast being very close to falling into the sea as coastal erosion has increased dramatically since there's no ice pack serving essentially as a buffer between the sea and our radar sites, to other installations along the coasts or in fire-prone zones being at risk due to changing weather patterns. No longer can we look at 100-year historical weather to predict how and where we should be investing in our facilities. So that's number one, just from a pure climate perspective. From an energy security perspective, more and more our military mission is reliant on electrons. So if you think of a remotely piloted aircraft, for example, where you've taken the pilot out of the airplane and put him or her on the ground several continents away, electricity and continuity of electricity is as critical for that mission as jet fuel is to a fighter jet, because you've essentially replaced jet fuel in some ways with electricity. So ensuring that continuity of electrons, and that's just one mission. When you look across all of the military missions, they have become more and more reliant on electricity over time. And we as a military have become more and more reliant on utilities, outsourcing more and more of our power generation. So really ensuring that continuity of electrons at a time when we have both physical threats against the system as well as cyber threats against the system is critical. And I had a person on my team in the Air Force who used to say, you can shut off my diesel supply chain for my backup gen sets, but you can't shut off my sun and you can't shut off my wind. So when you have a zero marginal cost fuel source that requires no supply chain, that increases your resilience and security if the grid goes down quite dramatically. There's so much more we could talk about here, Emily, around geopolitics, the mining of minerals and ores related with renewable energy, and the importance of thinking about those supply chains and which countries are really own those supply chains today, and how can we think differently about where we're sourcing critical minerals. All of that is really important as well. So that was a very short answer, but I tend to think of energy security as distinct from energy resilience. They are two different things. And then, of course, the geopolitics and sort of the opportunity to be a global leader in energy and really dominate the clean energy space, of course, is also critically important. So there's multiple elements to the energy security component.
Definitely. And I think one of our future panels in the coming days is going to be on specifically the geopolitics of the energy transition. So thank you for raising that. Miranda has informed me that she will hang on for the rest of the panel. So hopefully we'll get to hear from you again, Miranda. Thanks.
Thank you. And I look forward to hearing the panel.
Yes. And I would now like to turn to our panel. It is my pleasure to introduce Anne George, who is the Vice President for External Affairs and Corporate Communications at ISO New England, Mark Goodwin, who's the President and CEO of Apex Clean Energy and a Navy veteran, Tim Haid, who is the founder and COO of Scale Microgrid Solutions and an Air Force veteran, and Bob Yeager, who is President of Power and Water Solutions at Emerson Automation Solutions. Thank you all for being here today. So Given the significant disruptions to the grid that we've seen as a result of extreme weather events over the past year, I'd like to start out with a question for Bob on some of the opportunities we have to address these growing concerns around grid resilience. So, Bob, as we've witnessed these extreme weather events take their toll on energy infrastructure across the country, there's been a lot of discussion in Congress and at the state and federal levels about the need for grid resilience, which can take many forms. And one topic that I think a lot of Americans have probably heard of but don't completely understand is that of a smart grid. So could you discuss some of the work that energy companies, grid operators, and utilities are working on to make electrical infrastructure more resilient to extreme weather events and why that's important to decarbonization?
Well, sure, Emily. First, I would like to take a minute to acknowledge all the veterans on the line. I really appreciate your service to our country. It means a lot to me personally. And also, Emily, thanks for the opportunity to describe smart grid and the effects of decarbonization in about 5 minutes. So first, when I think about smart grid, it means, there's a lot of definitions. It means a lot of things to a lot of people. When I think about smart grid, I think of first the kind of the electrical component, like things, hardware components like phasor measurement units or synchrophasors that really do real-time measurements of voltage and current and frequency, amplitude, phase angle, things like that. So you kind of have these raw signals coming in. And then it's also advanced substation automation, step up and step down transformers that monitor the voltage across from high transmission lines down to distribution. It's also software. So it's transmission and distribution software. Specifically, advanced distribution management software. The grid is really changing. It's going through a lot of dynamics and fundamental change. It used to be that electricity flowed in one direction. So it was really a single direction of flow from the generating units all the way through the high voltage transmission to the distribution. But now with decarbonization, as Miranda talked about, and the introduction of renewable energy, a lot of these generating sources are what we say behind the meter. And because they're behind the meter, you get this reverse flow of electricity onto the grid. The utilities have a hard time dealing with that. They're dealing with it successfully, but that really requires something called net metering and advanced distribution software. So Miranda talked about the business inertia and how business inertia needs to change with decarbonization. And she also talked about the continuity of electricity and how important that is. I'm going to talk about real inertia because how the grid works is there's these large generating units, turbine generators bigger than the room that I'm sitting in, and there's this massive amounts of rotating metal that basically change the direction of electrons 60 times a second. And that is frequency, that is current, and the grid is very sensitive to frequency. So if the grid deviates in frequency, even a tenth of a hertz, there has to be action taken by the grid operators. This rotational energy from these large rotating devices converts from mechanical energy to electrical energy almost instantaneously. So these large rotating masses have sort of a dampening effect on the grid. It's kind of like cruise control on your car for the grid. And the reason why that's so important is because these large rotating masses can keep that frequency stable for sub-second intervals, while the primary frequency response operations from the generating units can take over and balance the frequency. So what that means to decarbonization and renewables is the renewable sources like wind and solar, they're really not alternating current like Tesla defines. They're direct current, and they don't have inertia. There's no rotating machinery in wind and solar generation. So by adding a lot of renewable generation to the grid, what happens is it creates a lack of inertia in some cases. And if you don't have the inertia to stabilize the grid, you can get grid instability. So while decarbonation is good, it's very good, the introduction of wind and solar and renewable energy can provide or create grid instability. So what the electric utilities are doing and operators are doing, there's really three things that you can do to work on grid stability. You can add more inertia to the system, more rotational energy, or you can add new technology that Miranda mentioned, like advanced battery technology, like the lithium flow batteries, for example, to do this, to have some inertia in the system instantaneously. You can add primary frequency response through kinetic energy, through advanced inverters that can convert kinetic energy in wind turbines to inertia. You can also add advanced automation software. So advanced automation software can run in the generating units and do automatic generation control to do this primary frequency response. And then finally, you can incorporate advanced distribution management software to really work on advanced load shedding, so that if there is a disturbance in frequency and you lose generation on the grid, that you can shed load intelligently to prevent widespread outages. So that's a 5-minute answer to that very complex question, Emily.
Thank you. That was a really comprehensive answer. And I'm glad you brought up transmission and battery storage. Those are two topics that I want to return to later in the discussion, especially since there's been a lot of policy movement around both those in recent days, really. But I'd like to turn now to Anne George. And I think this is it's good that she's picking up where you left off, because I think there's, a lot of consensus on the need for transmission and distribution management, grid stability, a smart grid more broadly. But the problem is that, even though there is this consensus, there's not a lot of alignment between, what's happening at the state and federal level, in the legislature, and what's happening in wholesale markets, which typically prioritize reliability and resource neutrality. So Anne, I'd like to go to you. Since both decarbonization and reliability are essential priorities in the coming years, what are some ways to create greater alignment between wholesale markets and state and federal level priorities focused on decarbonization?
So thanks, Emily, and good afternoon, everybody. And I want to add my thanks to the veterans that are in the audience. I appreciate you every day and what you do. So Emily, it's a great question, and it's actually top of mind in many of the ISOs, RTOs that operate wholesale markets. I'm from ISO New England, so we manage the wholesale markets for just the New England region, but we're also responsible for reliability of the bulk power system and that long-range planning of transmission for the system. And it really is all about ensuring a reliable system. And that's not only important for end users and Miranda's corporate customers, which reliability is hugely important to that. But it's also important because we're part of the Eastern Interconnection, which stretches from the East Coast out to the Rocky Mountains. And so we need to manage our system in a reliable way so that we don't cause problems in a large geographic area. And so, wholesale markets are the way that we bring forward resources to ensure that we have a reliable system. The states, and now we're starting to see more activity on the federal government side, looking to decarbonize. And so New England has been one of the most active states putting out, decarbonization goals, trying to shift the resource mix. The issue is that wholesale markets were created based on the premise, as you said, fuel neutrality, so that we didn't have markets favoring one type of resource over another, but also based on cost and the ability to compete on cost so that the markets can bring forward the most cost-effective set of resources to provide that reliable service. So, we've done a lot leading up to this point in time. Those wholesale markets have actually shifted resources to a much more efficient, clean, newer set of resources than we had when we first created wholesale markets. But now we're seeing the states really ramp up and see that 2050 deadline looming and saying, okay, we need to do more. And so now it's really trying to take that carbon intensity and value it in the wholesale markets. And that's been the challenge. In New England, we've been talking about these issues for the past 5+ years. We've tried other market mechanisms, but they really haven't worked at the speed that the states were looking for. So we actually in New England have launched a couple of studies to look at net carbon pricing. For years, we've said if there's a price on carbon that can flow into the wholesale markets, the markets will then value that and reflect that in the types of resources that clear the market. And you'll see the shift. The states historically have not wanted to pursue a price on carbon, and we haven't seen much movement at the federal level on that as well. I think Miranda was talking about a clean energy standard. That's an important step forward to really put a price and a demand for that clean energy into the system. So we're looking at net carbon pricing as a way that you could potentially have policymakers. We're not policymakers, but policymakers set that price and we'd flow that into the wholesale market. But if that's not the mechanism that is preferable, we're also looking at a forward clean energy market, which would be a standalone market that would look to buy on a regional basis clean energy. There's a lot of details to be worked out about that, but that's something that we're taking a look at to see if the region wants to move forward with that. One of the big factors that's at play here is dealing with the capacity market, and the Eastern RTOs all have a capacity market. And that's our market that sends the signal for new resources to get developed, but it also is a very important market for maintaining the existing resources that you need to meet your reliability standards. That market, we've tried different mechanisms, but we're looking at ways to remove some of the potential barriers to renewable resources coming into that market. The states really have looked outside of the markets to contract for renewable resources. And so we're looking at changing the capacity market to bring those into the capacity market so that we are getting the appropriate accounting for the capacity we need in New England. They're looking at this in the PJM, which is the Mid-Atlantic area, and in the New York ISO as well. I will say that as we move forward toward this, what we've labeled looking at the future grid, we are looking at how to best bring in those renewable resources and still maintain reliability. You have to have both because it's just something that is not going to be, you're going to lose momentum towards that decarbonization if you start to have major reliability concerns. And then Miranda touched on this, and then I'll stop here. Big part of that decarbonization is shifting things over to the electric system. We've seen some studies, not that ISO New England has done, but other consultants have done, that say, with the shift in whether it's the electric vehicles, whether it's the heating sources put onto the electric system, with that increased demand on the electric system, we're looking at potentially needing almost double of the resources that we have currently in New England on the system. So that's just a huge requirement that would need to be met. And we haven't even gotten to the place of really kind of drilling down and understanding the cost of that and understanding how we could potentially do that and have that all be all clean energy, renewable resources coming onto the system and what that would mean. So huge challenges ahead, but we all seem to be moving in the right direction, at least trying to figure out how best to do this while maintaining reliability. So thanks, Emily.
Yeah, I think you make a lot of valid points about the maintaining the cost effectiveness of renewables and placing a value on carbon intensity, which, as you mentioned, is going to be a challenge. We'll see what happens with budget reconciliation and a clean energy standard in coming weeks. But yes, regardless, it's going to be tough. And I think in addition to what you're mentioning about potentially valuing carbon intensity, there are also ways that renewables can be integrated effectively. And I'd like to turn to Tim here because I think he has some points to make on this. There's been a lot of debate in recent years around modeling for the best, most cost-effective way to decarbonize the grid and how investment should be allocated between utility scale renewables projects and distributed energy resources. Obviously, we need both. But in order to be cost effective, there are certain conditions under which it makes the most sense to deploy renewables. So Tim, would you be able to speak to some of the circumstances in which distributed energy resources, which I know is what you work on in your current job, in which these resources are uniquely suited to cost effectively decarbonize the grid? And if there are any changes that need to be made from either a policy perspective or a modeling perspective to ensure that the benefits of distributed renewables are accurately represented to taxpayers and public utility commissions.
Yeah, sure. Thanks, Emily. So I guess, to begin with, I just want to note that if there are any veterans here today who are thinking about starting a career in clean energy, I think you should definitely do it. Everything that we're talking about today, these goals are exceptionally ambitious, and there are millions of problems that we have to deal with if we're going to accomplish these goals, and we need problem solvers. And so I think that, the types of challenges that we're running up against consistently when we're talking about this energy transition are problems that are really uniquely suited to a veteran mindset. And we don't have enough veterans in the space right now, and we need more. And so if you're thinking about it, what I would say is, addressing the climate crisis is not only, the most important issue that we're dealing with as humanity, it's also the most lucrative. And so there's a huge opportunity here, not only to do something that really benefits society and the planet, but also to make a lot of money in the process. And I hope the veterans listening in take advantage of that opportunity. Specific to your question, just real quickly to build upon what Bob and Ann said, I just want to make sure that we're all on the same page with the definition of distributed energy resources. So, electricity has been a commercially viable product for a little over 100 years. And basically that entire time we've had one business model, which is really top down. So we build really big power plants, and then we connect it to end use customers through this really complex network of poles and wires. And for a long time, that made a lot of sense because economies of scale are what mattered in the electric power sector. But over the last 20 years, a bunch of things have happened, lots of technological changes. And now, in order to build sort of the electric grid that we need in the 21st century, and Bob mentioned this, we're kind of doing it two ways. We're doing it both top down and bottom up. And that really enhances the complexity of modeling, systems planning, everything to do with how you engineer and design a power grid. Generally speaking, there are two types of distributed energy resources, and I'll put them in sort of two buckets. There's load reduction tools, and I guess the most common load reduction tool is like a Nest thermostat, right? It's something that you can automate to reduce load at times when the grid needs you to reduce load. And then there's load generation tools and rooftop solar, batteries in your garage, things like that can actually provide electricity to the grid when the grid needs it. And the biggest problem that we have today is that we don't really understand how to properly value the energy that distributed energy resources are either taking off the grid or providing back to the grid. And so generally speaking, when we make these types of asset decisions, it's kind of a combination of utilities, public service commissions, and then a bunch of other stakeholders who are involved in this. And there's a pretty set model. It works a little differently in different regions of the country, but there's a pretty set model for how you sort of model, design, think about the cost benefits of those types of systems. And distributed energy resources kind of break that model. So the biggest thing that we're working on right now is trying to figure out how to incorporate distributed energy resource planning into these integrated resource plans that utilities and public service commissions build to sort of set the stage for how we're going to execute the energy transition over the next 15 to 20 years. But I think, the biggest thing that really isn't included in these models is the value of resilience. And that's probably the biggest thing we have to think about as the distributed energy industry going forward. Resilience is a big deal, right? I mean, the value of electricity to society is appreciating year after year after year. Having a power outage was inconvenient 40 years ago. If it had happened last year when we were all doing all of our work on Zoom, it would have been a total disaster. And it was a total disaster for some areas of the country. And so that the value of electricity is no longer sort of a commodity, and we have to price resilience into how we think about rate design. And that's really, really, really tricky to do. But generally speaking, today we think about resilience as sort of a private value. It's what matters to the customer. And therefore, the biggest distributed energy markets in the country are in places where there are recurring problems with the grid. So today, those two markets are California, where grid reliability is really suffering predominantly because of wildfire risk, and Texas, where grid reliability is really suffering predominantly because of market design. There are other pockets of the country where this stuff is really taking off. Florida, where there are a lot of concerns about hurricanes and storms. The Northeast, where really there's been sort of an aggregated response to Superstorm Sandy in 2012, and a lot of states and municipalities continue to work on it. But California and Texas are by far the biggest markets for distributed energy right now. And I think ultimately that's how you'll see distributed energy resources really gather market share as areas of the country where reliability and resilience are becoming recurring concerns. So I guess I'll pause there. I'm happy to take any questions later, but thanks so much.
Yeah, I want to stick on the topic of distributed energy resources really quickly. We're getting a lot of good questions from the audience. I appreciate everyone who's submitted. We actually have one from Maddie Carroll, who I believe is one of our Women Leaders in Energy Fellows. So thank you for submitting and attending, Maddie. So she has a question about net energy metering and distributed energy resources. How can net energy metering rate structures change to still encourage DER and renewable growth while not creating energy insecurity and unequitable availability to low-income communities? And she notes that an example of this happening is in California with the growth of rooftop solar. So would you be able to address that quickly, Tim?
Yeah, absolutely. Quickly. I'll do my best. So I could definitely address it. I'm not sure if I can address it quickly. So if there are any follow-up questions, please reach out. But yeah, right. So basically, net energy metering is the concept of if you have rooftop solar predominantly, you can get paid to put energy back onto the grid. And the way most public service commissions did this back in the day when rooftop solar wasn't really a big piece of the generation mix was they would just pay you the full retail rate of power, which isn't right? But it wasn't really a huge part of the market, and no one really cared that much about it. And so they just kind of did it that way. Now, in areas where rooftop solar is becoming a big part of the generation mix, that fundamental concept of paying the full retail rate for electricity produced by distributed energy resources is causing big problems in market design. And so the real answer here is that the value of distributed energy resources is definitely less than the retail rate, and it's definitely more than the wholesale rate. And we have to come up with a methodology for figuring out where in between we want to compensate distributed energy resources for the value they provide to the grid. And that's probably the most important debate that's happening. It's typically happening at the state level in public service commissions. So California, the CPUC just kicked off a big proceeding to try to figure this out. New York has been working on it for like 8 years. And what they came up with is something called VDERS, which is, okay, right? Not exactly what I would do, but it's okay. Other states like New Jersey, Massachusetts, Connecticut are all struggling with this as well. But the math is really, really complicated. And I think ultimately we're going to have to make a decision as an industry to sort of make sure that perfect isn't the enemy of good. One of the problems we have is all these models are based on a bunch of assumptions. And typically what happens is someone will produce a model and then there's sort of a peer review process and everyone hammers the assumptions. But we don't have a good way of doing that right now. And rooftop solar specifically is continuing to grow as part of the generation mix. And so we're going to have to come up with that methodology, sort of a commonly accepted methodology at some point soon.
Thank you. That was a great response. And for anyone who has follow-up questions, I encourage you to put them in the chat or the Q&A. I'd like to ask a question about renewable energy development, because I know there are a lot of challenges here, and I believe Mark Goodwin is uniquely positioned to talk about that. So even as costs of solar and wind have declined significantly over the past 10 years, aided in large part by these state and federal tax incentives, there are still a lot of challenges that constrain the ability of developers to access financing for renewable projects. So Mark, from your perspective as a developer, could you discuss some of the biggest challenges to project finance and what recommendations you would suggest for overcoming these challenges?
Sure. Thanks, Emily, and thanks for inviting me. Just want to say a couple of high-level things before I go to that question. But as stated earlier, I'm a Navy veteran, and I was in the shoes of many of the people in the audience here 20 plus years ago. And I, as Tim mentioned, I couldn't encourage veterans more to think about a career in the clean energy business. Right now, as Emily stated, the Biden goals of net zero utility sector by 2035 require everyone who's in the utility sector to double, triple, potentially quadruple what we're doing on an annual basis. And that's huge. We are a large industry already, and we need utility solar, utility wind, distributed energy, offshore wind, battery storage to ramp up significantly. And what that means is there are a wide spectrum of career opportunities. I started off on the kind of the technology side of the wind business, but there is so much to do, whether you're a business, want to be a business person, or in technology, or in operations, or in policy, or the law. We need quality people in the military. Really provides a lot of the skill set that's important for us to achieve our mission. Emily, to your question, there's a lot of policy levers that are moving right now to enable us to get to multiples of what we're installing right now to achieve those goals. And I agree with what Miranda said earlier, is that the utility sector is the easiest part of the economy to decarbonize, but it is not easy. And what that means is it's rewarding for people in this sector because you can achieve results. You can put steel in the ground. You can build projects. But a constraint that we've had in achieving, that, and much of what we do at Apex Clean Energy, we are a utility scale renewable energy company. We're developing wind, utility solar. We are doing distributed. We are pioneering in the green fuels sector. But to achieve the expansion that we need to open up project finance. So one of the things that we're promoting is to transition the traditional tax equity finance structure from third-party tax equity to something that is potentially in the reconciliation bill called direct pay. And that would open up finance to not just the handful of tax equity investors that invest in wind and solar projects today, but to hundreds of commercial banks and investors that will be able to come into project finance. With that, along with a clean energy standard, will really supercharge our ability to increase what we're bringing onto the grid, along with transmission policy that Anne was talking about earlier. So it is just so much opportunity in our business right now. We know the levers that we need to pull in order for us to expand what we're doing, and accelerate energy transition, which is my mission. And just to close on the military side of things, I got into this business over 20 years ago because as a Navy veteran, I went in the first Gulf War vintage. I did 3 deployments to the Persian Gulf. What I understood was that much of the mission of the DoD is about energy security. It's about maintaining, free trade around the world. And what better to do in my civilian career than to improve energy security by building clean energy right here at home. So it's an exciting time for veterans like yourself to come into a great industry.
Thanks, Mark. I think we're getting a little short on time here, and I want to give everyone the chance to speak at least once more. And since you mentioned the infrastructure bill and budget reconciliation, I want to give everyone the chance to respond to some of the things that are happening in the Biden administration right now. So if we could just quickly do a round robin on what initiatives you find most promising in the Biden administration as they relate to any aspects of energy, clean energy deployment, and some that might not be your top priorities, but are not talked about enough. And to whatever extent you can make your remarks about clean energy employment, I think that would be of interest to our audience, especially those who are looking to transition into the field. So Mark, since you just spoke, how about you respond first?
One of the areas which is, to me, is really exciting and potentially a subject of policy adjustments is green fuels, green hydrogen, green ammonia. We just announced a very large power purchase agreement with Plug Power, which is a company that manufactures, among other things, they make fuel cells, but they also make utility scale electrolyzers. And what we're doing is we're going to use wind energy to power that electrolyzer to produce green hydrogen, which will be used, among other things, for their material handling business. This is exciting because it's delving into other parts of the economy. It's using our capabilities in utility wind and solar to decarbonize a part of the material handling sector. We can do the same thing with the transport sector. Maritime resources are coming to us. The shipping industry is, how can I produce green hydrogen or ammonia to power the vessels? And it's a huge amount of energy and part of the carbon footprint. So that's exciting. We're also working in battery storage right now. Most of it on a short-term discharge model, but it's exciting to hear about technology with long duration energy battery storage, and that's going to be a key to increasing penetration. Right now, reliability is very strong with the penetration that we have of renewables, but if we're going to get to 80-90% renewables, then we need long duration storage, and we're working on that too.
Yeah, thanks for hitting on battery storage and LDS specifically. There's so much more that I think we could discuss. This conversation could go on for another hour. But Anne, I'd like to hear your response. And for the rest of the panelists, if you could please keep your remarks to about 1 minute or less. We're getting up on about 5 minutes from the close of the session.
So Emily, I'll be really quick. Again, a carbon price, a national carbon price would be wonderful. I think it really would push everything towards in the right direction to see the innovation and see the markets turn over. Mark just touched on hydrogen and long duration batteries. I think if you really are going to be serious about decarbonizing the electric system, especially, you look at a region like New England, the long duration battery is absolutely necessary to get us through some of the potential cold weather events that happen. The short duration batteries, while they might be helpful, they just aren't going to be that reliability resource we need. So I'll just stick to that. Transmission also is hugely important. I know that that's a big factor in the infrastructure bill. Offshore wind is coming on strong, and transmission to integrate offshore wind. If you look at all of the potential development out there, the transmission networks that will be needed to do that is going to be key to building that industry and getting that started. So thank you.
Bob?
Yeah, thanks, Emily. I think one of the most significant things from the Biden administration now is the executive order on cybersecurity. I think it's, I mentioned before on the smart grid and the introduction of advanced distribution management software, and how additional software will be layered on to do things like load shedding and advanced generation control and primary frequency response. It's critical that that's protected by cybersecurity regulation. I think the utilities need that guidance. I think it's important that it's generated from Washington. I think it's important that they start with the government agencies first and create standards and create infrastructure from cybersecurity that can be utilized by the electric utilities, and create not only the inertia and stability that we need from a physical perspective on the grid, from a software perspective.
And Tim?
Yeah, so number one thing I'm excited about is the clean energy standard. Look, I think that, trying to transition the US electric grid to 100% clean electricity in 15 years is a borderline insane goal, but it's what we have to do, especially if you sort of understand the geopolitical situation and how important it is for the US to get this done right first. And so, that starts with putting the policy in place, right? And so I think the biggest thing that hopefully you can get through the reconciliation bill is this clean energy standard. I think what we're now calling a clean energy payment program, to make sure the parliamentarians happy. But that would be my number one thing. And I think it's incredibly important that we get that done.
Great, thanks. And last but not least, Miranda.
So I would agree with everything that everybody else is excited about. So I'm going to take a slightly different tact. The federal government and the Biden administration are not only policymakers, but they're also extraordinarily large consumers of power. I'm very excited that the administration has taken a technology neutral, outcome focused to their own procurement, and focused on the federal government agencies procuring zero carbon energy for every facility all the time. It's a 24/7 goal. It's big, hairy, audacious. Very few in the private sector have gone there, and there aren't easy solutions. So I'm really excited to see the administration, as well as Congress, as well as FERC, be focused on taking a technology neutral, greenhouse gas outcome focused approach to this problem. And I would put in one more plug for bold federal level ambition, but also unlocking markets through organized markets and wholesale markets that allows for energy democracy across the country, so that we can get the right technologies in the right places.
Thanks, Miranda. I think that's a great note to end on. I want to apologize to everyone whose questions we didn't get to. There were quite a few. For all of you, I encourage you to download the app if you haven't already, and connect with the panelists on this panel and of other panels throughout the coming days. Thank you again to all the attendees who were able to join us for this important and productive conversation. And thanks again to all the panelists for being here to share your perspectives. If you would like to rewatch today's event or share the stream with a colleague, a cached replay will be available on the Atlantic Council YouTube channel and on all our social media platforms. And coming up next in our conference program, Make sure to tune in at 2 p.m. Eastern for an exciting panel discussion on the future of decarbonized transportation with leading figures in the industry. And if you're interested in meeting with company recruiters, join our designated info sessions with Apex Clean Energy and Emerson over the next hour through our event app. Thank you again, and catch you all there.